Welcome to Brain Vision.
In this problem, we have a cart pushing a block, and we want to know the acceleration such that the block does not fall to the ground. In this case, our friction force and normal force directions are kind of inverted. The normal force is now going horizontal, and the friction force is going vertical. Now we know that the sum of the forces in the y direction must be 0 because there's no acceleration in the y direction. That's a condition imposed by the problem. So this implies that the force of the friction is equal to m times g. And so the force of the friction is equal to mu s times n. That's just the definition of a frictional force. And then now plugging in the value of our frictional force, we get mg is equal to mu s times n. Now we're ready to apply Newton's second law in the x direction. In this case, there is an acceleration, so we can't set it equal to 0. We have to set it equal to m times a. Now the sum of the forces in the x direction is just n, so we know n is equal to ma. And we can also plug in a value for n because of this here. Doing that, we get that mg over mu s, which is just n, is equal to ma. We can cancel a factor of n and solve for a, and we get g over mu s. This is the required acceleration that we have to impart to the cart to keep the block floating there. And to an observer on the cart, it does look like the block is just floating there, although they would feel the acceleration and know why the block is just floating there.